accomplishing a rotation, right? And so I also told you that the Grover operator can be written in Dirac notation and it can be written in matrix notation. So we have all of these things floating around, different viewpoints of it. So if you consider our Grover operator in matrix notation, this is what it looks like. And based upon our geometric viewpoint, we see that there's this trigonometric relationship between the angle of rotation and the number of solutions, right? And this, and I gave it to you explicitly. So the angle of rotation of that Grover operator has this relationship here with the number of solutions. So we're saying the number of solutions is P. Remember, we're looking for the number of fixed points, so we represent that by P. And M is the number of elements you're searching amongst. And so here's our Grover operator. So what is the point? So if we can find the eigenvalues of the Grover operator, then we can know what the theta is. And if we know what the theta is, we know what the number of solutions are. So that's the way the logic goes. And so, to conclude, there are a couple of more things we can say. So this is really aimed more toward the group theorists. So I apologize for those of you who are non-group theorists. So it turns out if we tweak these questions a little bit, then we can answer some questions about groups. So if you set your subgroup, your finite subgroup of your automorphism group, if you let that be the set of IA automorphisms, then the invariant algorithm can be used to determine if the subgroup is an IA automorphism invariant subgroup. So now I remind you that IA automorphisms are those that act as the identity on the abelianization of a group. So you're asking a specific question about invariance. And then another question that's interesting is, if you, where are we? If you have a group and you view it as the quotient group of a free group with R, where R are the relators, and R is the kernel of the natural epimorphism, I'm just waving my hands and saying R represents our relators. Then the stabilizer of R consists of the automorphisms that stabilize R, and this is fixing them element-wise. So remember our fixed S before? Our fixed S consisted of group elements that were fixed by S. But here this is slightly different. Your stabilizer is actually a subgroup of the automorphism group. So the stabilizer consists of automorphisms, not group elements. If you put your subgroup equal to R, and you let our subgroup of the automorphism group be the whole automorphism group, then our fixed S algorithm 2, for this algorithm, your stabilizer R is going to be that S output. You're actually able to compute the stabilizer. So by tweaking certain things, you're able to answer some more general questions. And I'm sure there are more, we just haven't thought of them yet, right? Okay. Well, thank you for your attention. Does anyone have any questions?
Thank you. Are there any questions?
I have lots of them.
Can they be answered? That is the question.
Can they be answered? Root and time.
Kati?
I missed, unfortunately, when you first talked about whether the automorphism group admits a fixed point free automorphism. This is nitpicky. You don't mean whether the automorphism group will have an automorphism that will fix it. But you mean whether the automorphism group contains an automorphism,
that's fixed.
Because the admit would be easily misunderstood.
Yes, it's just language, that's all it is. I'm saying, does there exist an automorphism in there that's
Amongst
fixed
those,
point?
yeah.
Yes.
So does it contain one?
Does it contain?
Mhm.
That's what I'm looking for.
I've actually been editing that part in the paper.
Yes, we have to. We're
Good.
working on
Admitting
it.
is not the right
Not
word.
Admitting is not the right word. We have
Yeah.
to, yeah.
Containing is better.
Containing is the
Contains,
right word.
yeah. Good.
Thanks, Kathy.
That's, that's it.
Such a nitpicker.
She's a very,
She's got me on
Always
tape with that. Now
big
she's got all these witnesses.
Any other questions? So let's thank Marianna for her very lovely talk.
Thank you very much.
So we start in 5 minutes for Walter's talk.
Good. 5 minutes. That's all I need.
Thank you.